For this video, I'd like to talk about the concept of an intercept, or namely when you have a line that this line is going to intercept both the y-axis and the x-axis. So for instance, this point right here we call the x-intercept. And with the x-intercept, it's going to be a different x value depending on what the equation is. But you can notice that the y value is the same for any point on this line, namely that y is equal to 0. So y values on this line are equal to 0. And then this point right here is what we call the y-intercept, since this is where the line crosses our y-axis. And for these, the y value will be different depending on the equation, but the x value, notice, as an x value of 0. So essentially all points along this line, no matter where it crosses, all of these points have an x value of 0. So one way to remember this is that you want to think in terms of opposites. So for the x-intercept, that's when y is equal to 0, and for the y-intercept, that's when x is equal to 0. Or you could think about it that for the x-intercept, you're trying to find the x value, and for the y-intercept, you're trying to find the y value, and then the opposite value is equal to 0. So for this one, you're trying to find the x value, and the opposite of that, namely the y value, we know is equal to 0. So with this in mind, let's try and do some different example problems. So for this one, we're given a graph, and we need to find the x and the y-intercepts. So that's where it crosses this y-axis here and the x-axis down here. So this is our x-intercept, and it's at the point minus 250 for the x value and a y value of 0, whereas this y-intercept, it's at an x value of 0. Remember, all points along this line have an x value of 0, and the y value is at 100. So these are the two intercepts, minus 250, 0, and 0, 100. And moving on to the next problem, we need to find the intercepts of this line. So in this case, we're given an equation. So let me just rewrite this. Minus 4x plus 7y equals 3. And let's find the x-intercept first. And we know that the x-intercept is when y is equal to 0. So what I'm going to do is anywhere I see y, I'm going to plug in 0. So essentially, this entire term will go away because 7 times 0 is just 0. So let me rewrite that. So we have minus 4x plus 7 times 0 equals 3. And like I said, this term just goes away, so you get minus 4x equals 3. And dividing everything by minus 4, you find that x is minus 3/4. So this x-intercept is at an x value of minus 3/4 and a y value of 0. And now we want to do the same thing, but for the y-intercept. And remember that this is when the x value is equal to 0. So we're going to plug in 0 for x, which will essentially make this entire term go away. But let's write that out. So we have that minus 4 times 0 plus 7y equals 3. And minus 4 times 0 is 0, so this term goes away. And we get 7y equals 3. And dividing everything by 7, we get that y is 3/7. So this line also has the intercept that goes to the point 0, 3/7. And basically, anytime you have the equation of the line written in standard form, where both x and y are on the same side of the equation, it's generally fairly quick to find the intercepts, since plugging in 0 here just makes that go away, or plugging in 0 here makes that go away, and then it's simply just division by whatever this coefficient on x or y is. Now with that in mind, let's look at a different type of problem where it's essentially not in standard form. But ultimately, we're going to do the same process. So let's start with this x-intercept, which is when y is equal to 0. So let me rewrite the equation. So we have minus 4x plus 7 equals 2y minus 3. And we're going to set first y is equal to 0. So essentially this term will vanish since 2 times 0 is just 0. But let me write this out more explicitly. So we have minus 4x plus 7 equals 2 times 0 minus 3. But like I said, 2 times 0 is just 0, so that goes away. And we get minus 4x plus 7 equals minus 3. And now we want to solve for x. So I'm going to subtract 7 from each side. So you get minus 4x is equal to minus 3 minus 7, which would be minus 10. And dividing everything by minus 4 and simplifying, you get that x is equal to 5 divided by 2. So our x-intercept for this equation is at 5/2, 0. And with that, we can start looking for the y-intercept, which is when x is equal to 0. So we go to this equation again, and wherever we see an x, we replace it with 0. So essentially this term will vanish, and then we can solve for y. So to do that, let me write that out. We have minus 4 times 0 plus 7 equals 2y minus 3. And so this term goes away, so that we get 7 is 2y minus 3. And I'm going to add 3 to each side, so that 10 is 2y. And finally, dividing everything by 2, we get that y is equal to 5. So we also found the y-intercept at 0, 5. So these are the two intercepts for this equation, 5/2, 0, and 0, 5. And let's do one final question. And this one's probably the most difficult because we have to find the intercept based off of a table. So in this case, we want to find the y-intercept. So remember, that's when x is equal to 0. And basically what we have to do is figure out the pattern. So it looks like we're taking equal sized steps in the x direction. It looks like going from 24 to 36 that we're going up 12. And then we do the same thing when going from 36 to 48. So it looks like we're taking steps of 12. And then we want to think about how much the y values are jumping. So it looks like when we do a step of 12 in the x direction, that y has 9 added to it. And it looks like that same pattern continues. Going from 1 to 10, we again add 9. So basically, if we want to go back to an x value of 0, we would have to subtract 12 twice. So minus 12 and minus 12, which means that we would have to continue the pattern on the y side as well. Namely, we would have to subtract 9 twice. Since every time you add 12, you add 9, or every time you subtract 12 from x, you subtract 9 from y. So the pattern continues in both directions. And working backwards to find an x value of 0, we can see that the y value, we would just take this minus 8 and then subtract 9 from it twice. And after the first time, you get minus 17, and then minus 9 again brings us to minus 26. So essentially, our y-intercept would have an x value of 0 and a y value of minus 26.